Hi, welcome to this Math Spiral video. My name is Sarah Powell and I work at the University of Texas at Austin. This spiral video right here was a request from a spiral teacher. So we are going to think about how we can use the partial quotient strategy with decimals. Now there's a lot of different scenarios where we might want to use partial quotients with decimals. So first we're going to think about dividing 142 by 8. And then I'm going to think about dividing 14 and 2/10, or I'm going to go ahead and shorten that to 14.2 divided by 8. And then we're going to look at what it means to divide 142 by 8/10. So that's a lot of math. Buckle in. Let's go ahead and get started. So the first problem that we are going to do is 142 divided by 8. And we are using the partial quotients strategy. With the partial quotient strategy, I'm always going to draw a vertical line down from the end of the long division bracket so that I separate my workspace from my partial quotients. Now we've got that done, let's go ahead and start doing some of the division. I first ask myself, how many groups of 8 can I make if I have 142? Well, I don't know the exact quotient right now, which is why we are using our partial quotients. But I do know some things. I do know that if I multiply 8 times 10, 8 times 10 is 80. So 10 is one of my partial quotients. I'll go ahead and subtract 142 minus 80, and then I have remaining 62. So then the next question I ask myself is how many groups of 8 can I make if I have 62? Well, let's see. I know that 8 times 7 is 56. So 7 is my partial quotient. I'll go ahead and subtract 62 minus 56, and then I have 6 remaining. The next question I ask myself is how many groups of 8 can I make if I have 6? Now this is where many times we will write a remainder. So what I would do here is I would add my partial quotients to 17, and I would say 17 remainder 6. But we can use decimals, and we can keep going to figure out how we would solve this problem. So I want to think about how many groups of 8 I can make if I have 6. So I'm not exactly sure, but I could say, well, let's see, I could make 0.5 groups of 8. And so 8 times 0.5, or 8 times 5/10, that would equal 4. So 6 minus 4 is 2. And then I'm going to keep going here. I'm going to actually have to extend that vertical line. All right. How many groups of 8 can I make if I have 2? Well, if I have 25 hundredths, or 0.25, 0.25 times 8 is 2. My gosh, you all, look what we did there. 2 minus 2 is 0. I don't have to think about making any more groups of 8. But I'm not finished because I now need to figure out the final quotient to this problem. So I'm going to go ahead and add these together. So I have 17, 17 and a half, and 17 and a half plus 0.25, or 25 hundredths. That is 17 and 75 hundredths, or 17.75. That ends up being our quotient. So that's one way that we can use our partial quotients strategy with decimals. There, we were focused on not having a remainder, but being able to show that remainder in decimal form. So that was one example, and as I promised earlier, I have 2 more. So let me erase, and I'll be right back to look at our next example. Okay, I did all of my erasing, and I wrote a new problem here. We are also going to use the partial quotient strategy, and we're also going to think about decimals. So here, I am now going to think about 14 and 2/10 divided by 8. Just as before with the partial quotient strategy, we're always going to draw a vertical line down from the end of the long division bracket to separate my partial quotients from my workspace. So let's go ahead and ask ourselves some questions. How many groups of 8 can we make if we have 14 and 2/10? Well, if I knew the answer to that, we wouldn't have to do this problem, right? but I'm going to use some things that are known by me. I may solve this problem differently from you, but let's think about what we do know. I don't know how many groups of 8 we can make if we have 14 and 2/10, but I do know that 8 times 1 is 8. 8 times 1 is 8, so I'll go ahead and write that right there. I could write it in its decimal form to hold the place value. And so I've got one group of 8. I'll go ahead and subtract here. And what do I have remaining? I have 6 and 2/10. How many groups of 8 can I make if I have 6 and 2/10? I don't know. But I do know that if I have half or 0.5 or 5/10 of a group of 8, 8 times 0.5 is 4. I could use my decimal place to hold place value right there. I'll go ahead and subtract. And what do I have remaining? 2 and 2/10. Now let's think about what we have to do. Well, how many groups of 8 can I make if I have 2 and 2/10? Well, I know that 8 times, I'll do 25 hundredths. 8 times 25 hundredths is 2. So I'll go ahead and do the multiplication there and then the subtraction. And what do I have remaining? 0.2 or 2/10. And then I need to ask myself, well, how many groups of 8 can I make if I have 2/10? Now, these questions are hard questions. They're hard for adults to think about, and they're probably very hard for students in grades 4 and 5 to talk about. And so that may be one of the reasons that this partial quotient strategy might not always be your go-to strategy, but I'm also going to talk about a little bit of a workaround as soon as I finish this problem. But let's think. If I have 2/10 and I divide that by 8, that would be 25 thousandths. So 8 times 25 thousandths is 2/10. And if I subtract those, I end with 0. I don't have to make any more groups of 8. Shoo! Now it's time to add these partial quotients here. So I'm going to add 1.5, 1 and 5/10, so that's 1.5. I add the 2500, so that's 1.75. And then if I add my 25 thousandths, what do I end up with here? I end up with 1 and 775 thousandths. So that is my quotient. And I can check my work. If I multiply 1 and 775 thousandths and I multiply that by 8, I will get a product of 14.2 or 14 and 2/10. Now, back to our discussion piece. Those were some really complicated questions and really complicated decimals that I was working with there. And not all students in grades 4 and 5 might be able to do that. And so what are we to do? Well, a lot of people will move the decimal point just like you typically do with that traditional long division. You can also do that here with the partial quotient strategy. And then you just think, oh, once you've moved the decimal point, I might move it here to the right one place value. And then when I calculate my quotient, I'm going to move it back into place. So that is a workaround if you think it's pretty complicated to ask yourself, for example, how many groups of 8 can I make if I have 2/10? Now I need to erase this workspace, and then I'm going to be back to look at a third example. See you in a minute. Last but not least, let's work on this problem here. 142 divided by 8/10 or 0.8. Let's set this up with our partial quotients. We're going to draw that vertical line down from the long division bracket to separate our workspace from our partial quotients. So let's think about how we could solve this problem. I'm going to ask myself, how many sets of 8/10 are there in 142? Well, goodness, I don't really know, but I do know some familiar things. I do know that if I multiply 0.8 or 8/10 by 100, that gives me, let's see, 100 times 0.8 is 80. And I'll go ahead and subtract that from 142, and I have 62 remaining. Now I ask myself, how many groups of 8/10 can I make if I have 62? Well, goodness, I'm not exactly sure, but I do know that if I make 50 groups of 0.8, then I would have 40. So 62 minus 40, I have 22 remaining. Then I might ask myself, well, how many groups of 0.8 do you have if you have 22? Well, goodness, I'm not really sure, but I could say, well, if I have 25 groups of 0.8, that would get me to 20. 25 times 0.8 is 20. And then I have 2 remaining. And then I think about, well, how many groups of 0.8 do I have if I have 2 of something? Well, gosh, I'm going to have to get pretty creative here, right? So I could have 2 groups. Let's see. 2 groups of 0.8 would get me to 1. And this is where I should have written this a little bit to the right. 1 6/10. I'll go ahead and put my decimal in there to subtract. Now I have 0.4. And then how many groups of 8? I'll show that sign right there. How many groups of 8 do I have if I have 0.4? Well, I would have 0.5, or half. And so 0.5 times 0.8 is 0.4. There we go. Subtract, and now I have 0. I'm running out of workspace. You didn't even have to see that. But what we do have to see is the adding of these partial quotients. I'm going to do this right here. If I have 100 plus 50, I'll add those together. That's 150. Then I add in 25. That is 175. Then I add in 2. So that is 177. And then I add in 5/10. That is 177 and 5/10. So my final quotient is 177 and 5/10. So that was yet another example where we can use this partial quotient strategy to work on division of decimals. And in this example, we had decimals and whole numbers. Now, as I talked about with our second example, those questions sometimes are hard to answer. Like, how many groups of 0.8 do I have if I have 0.4? Ooh, I'm not always sure. So what do a lot of people do? They will often move this decimal point to begin with. Here in that example, that would add a 0 there. So I would think about dividing 1,420 by 8 instead of 142 by 0.8 or 8/10. Let me erase, and I'll see you in just a minute. Well, that was a lot of division for today, but I hope that you found it helpful, and it might help you understand whether you want to use the partial quotients strategy for division, or if you want to use some other strategies, such as the traditional or standard algorithm. Thank you so much for joining into this Math Spiral video. Hopefully you will watch some of our other videos where we talk a lot more about math. Have a good day.